Let's take a look at exponential and logarithmic equations. And first thing we'll talk about is the equality of exponents. Some books refer to this as a property. This says if you got b to the p power is equal to b to the q power, then you set the exponents equal to each other. So you'll set p equals q. Now typically b's are numbers, so you have like 2 to the 5th power is equal to 2 to the x power, for example. Let's take a look at a problem dealing with this. We've got 2 to the x is equal to 16. And it says solve each exponential equation by expressing each side as a power of the same base and then equating exponents. This is the equality of exponents. I'm going to start with my larger number, and I'm going to try to rewrite it as a smaller number to a power. Well, I can rewrite 16 as 2 to the 4th power. Now the equality of exponents says if you could write this as 2 to the power equals 2 to the power, you can set the exponents equal to each other. And once we set them equal to each other, we're actually done because x is equal to 4. Let's look at another one of those. Here we have 3 to the 5x minus 1 is equal to 9. Same instructions. We're going to start with the larger number, or we're going to try to rewrite it as the other number to a power. Well, I can rewrite that as 3 squared. Now, both sides are 3 to a power, so the equality of exponents, I'll set the exponents equal to each other. And once I do that, it's a linear equation, and I just follow my steps there. You know, get rid of parentheses, get rid of fractions, get everything with an x on one side, numbers on the other. So I'll take the -1 to the right side, and it becomes a +1. At any step, combine together numbers. 2 plus 1 is 3. And the last step is to divide both sides by the number in front of your x. So we'll divide both sides by 5. Those 5s will cancel. And we got x is equal to 3/5. Let's look at another one. We got 9 to the x plus 2 equals 27. I start with the larger number, and there's no way for me to rewrite that as 9 to a power. So what we do is we look at both sides and see if we can rewrite both of them as a number to a power. Well, 9 is 3 squared. Now notice when I rewrite it as 3 squared, I put the 2 up right next to the what was already there in the exponent, with parentheses around it. And 27 is 3 to the 3rd power. So now I rewrote both of them as 3 to a power, so I can set the exponents equal to each other. And this is a linear equation. First step, get rid of parentheses using a distributive property. 2 times x is 2x, 2 times 2 is 4. Get everything with an x on one side, numbers on the other side, so I'll take the 4 over to the right side. You take anything across your equals, the sign changes, so it becomes a -4. Combine together numbers at any step. 3 minus 4 gives you -1. And last step, divide both sides by 2. Those 2's cancel. And we got x is equal to -1/2. And that's our answer. Now in this problem, we have 5 to the x power is equal 1 over the 4th root of 5. Well, the 4th root of 5, I can rewrite that as 5 to the 1/4 power. Remember, whatever number is in this little slot right here, that's your index. That goes in your denominator. Whatever power is inside goes up on top, and this is like 5 to the 1st, so we have 1 there. Now we want to get that out of the exponent, so we're going to take the 5 to the 1/4 and move it up on top. Remember, when you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So 5 to the +1/4, when I take it up on top, becomes 5 to the -1/4. Well, now they're both 5 to a power, so I can set the exponents equal to each other. So I got x equals negative 1/4. Let's take a look at another example of that. Got 16 to the x minus 2 equals 8 to the 3x minus 1. Well, if I start with a larger number, start with 16, there's no way I can rewrite 16 as 8 to a power, so I'll look at both sides. I can rewrite both of them as 2 to a power, it looks like. 16 is 2 to the 4th, so I'll put the 4 next to the x minus 2. And 8 is 2 to the 3rd, and I'll put the 3 next to the 3x minus 1. Well, now they're both 2 to the power, so I can drop the 2's, and I got 4 times x minus 2 equals 3 times 3x minus 1. There are linear equations at this point, so get rid of parentheses. 4 times x is 4x, 4 times negative 2 is negative 8. 3 times 3x gives you 9x, and 3 times negative 1 gives you negative 3. Get everything with an x on one side, numbers on the other side. So I'll take the 9x to the left side and the negative 8 to the right side. Take anything cross equals, the sign changes. So the 9x becomes negative. The negative 8 becomes positive. No matter where you are in math, combine together like terms, combine together numbers. 4x minus 9x gives you a negative 5x. Negative 3 plus 8 gives you 5. And last step, divide both sides by the number in front of your x. So we'll divide both sides by negative 5. And we get x is equal to negative 1. Now, let me start a new page. And let's look at the next problem. You got 15 to the x is equal to 112. You notice there's no way to rewrite 112 as 15 to a power. And I can't look at both sides and rewrite each of them as a number to a power. So we're going to have a different way of solving the other types of exponential equations. Exponential equations when you got a variable in the exponent. So exponential equations. A little story leading into this. This has always been kind of a hard topic for people in
virus database has been updated.
Go away, Avast. This has always been kind of a hard topic for those in college algebra. My students have struggled with it and so forth, and so I sat down and I came up with a document that step by step walked through how to solve these. You couldn't go wrong with it. Beautiful document. Best piece of work I've ever done. I was about ready to publish it and to get my name famous and everything. Beautiful document. It was 6 pages long. I gave it to the students, and I did my usual spiel, going over how to solve exponential equations, and sent them off on their way. They came back with as many questions as before. That beautiful document I was so proud of was actually one of the stupidest things I'd ever done. 6 pages. Nobody reads 6 pages. Very stupid. I deleted that off my hard drive. I destroyed all copies I had of it. Now, I've shortened it quite a bit. Now, in the process of shortening it, it no longer handles 100% of the problems. So the steps I'm about ready to give you here will handle about 95% of the problems. We'll show one example of a type it doesn't handle. But now that it's shorter, students actually will read this and follow these steps. Okay, first part, or first step. Get the part with the variable in the exponent by itself. We don't want any numbers in front of it, any numbers after it. We'll see this with examples. Step 2, take natural log of both sides. Take ln of both sides. Step 3, use properties of logs to get the variable out of the exponent. And step 4, solve for x. And that's pretty vague. We were solving for x initially, but it's probably a linear equation at this point, but it could be a quadratic if you had a bizarre enough problem. But these are the 4 steps we're gonna follow. So let's look at number 6. 15 to the x is equal to 112. First step, get the part of the variable and the exponent by itself. Well, this is the part of the variable and the exponent. There's no numbers in front of it, there's no numbers after it, so it's by itself. Step 2, take natural log of both sides. So we'll take ln of both sides. Step 3, use properties of logs to get the variable out of the exponent. Well, remember, if we have log of something and it's to a power, you can take that power and put it out in front. So we got x, natural log of 15, equals natural log of 112. Now I say solve for x in step 4. Well, natural log of 15, that's just a number. Now think what you did when you had a number like this. 7x is equal to 14. To get the x by itself, you divided both sides by 7, divided by that number. Since natural log of 15 is just a number, we're going to divide both sides by natural log of 15. We're going to do that. These natural log of 15s cancel. And we got x is equal to natural log of 112 over natural log of 15. Now, this is the first part. It says express the solution set in terms of natural logs. It then says then use a calculator to come up with the 2 decimal places. Personally, I like this answer right here. So I will plug one of these in the calculator just so you can see it. To me, the calculator is the boring part. So we got natural log ln of 112. You have to make sure you put a closing parentheses, divide by natural log of 15. Enter. 2 decimal places, we got 1.74. Now, what I circled here is an exact answer, and what we'll put down right below it is an approximation. Usually in math, we like exact answers. Let's look at another problem. So we got e to the 7x minus 1 minus 5 equals 53. Now, first step, get the part with the variable and the exponent by itself. The part of the variable and the exponent is the e to the 7x minus 1. We don't have it by itself, we got a negative 5 behind it, so we're going to take that negative 5 and move it to the right side. So we got e to the 7x minus 1 equals 53 plus 5. So we got e to the 7x minus 1 equals 58. Now our next step says to take ln of both sides. So we'll take ln of both sides, natural log. Now step 3, use properties of logs to get the variable out of the exponent. Now remember what the base of ln is. It's e. If I were to put it there, this base is e. Well, remember what happens when these match. These e's are the same. The natural log and the e's are going to cancel, and we're just left with 7x minus 1. It's still a property of the logs, not the same one we did in that first problem. We like problems that have e's in them because it always cancels away really nice like that. Well, now I'm going to take the negative 1 to the right side. It becomes a positive 1. And then last step is to divide both sides by number in front of our x. So we'll divide both sides by 7. This is just a linear equation. And those cancel. And we got x is equal to 1 plus natural log of 58 over 7. And you can plug that in the calculator if you want. The key to putting your calculator is put parentheses around top, parentheses around the bottom. Anytime you have more than a single number or single variable in top or bottom of your fraction on a TI3, TI4, you have to put parentheses around it. take a look at the next example. We got 4 to the x minus 7 equals 13. First step, get the part with the variable and the exponent by itself. Well, the part of the variable and the exponent is 4 to the x minus 7, and it's by itself. There's no numbers in front of it, no numbers after it. So step 2, take natural log of both sides. So we got ln of 4 to the x minus 7 power equals ln of 13, natural log. Step 3, use properties of logs to get the variable out of the exponent. Remember, we had a property that said if you have a log of something to a power, you can take the power and put it out in front. So put the x minus 7 out in front. Now keep in mind that natural log of 4 is just a number. If I plug that in my calculator, it'll give me some kind of decimal. Whenever we have a number next to parentheses, like this, we use the distributive property, multiply it through. Well, this is no different. It being a natural log, it's still just a number. So we're going to take natural log of 4 times x and times negative 7. These are pretty easy to multiply together. You just put them next to each other. So we got x, natural log of 7. Try it again. X, natural log of 4 minus 7 natural log of 4 equals ln of 13. Okay, now this is a linear equation at this point, so we're going to solve for x. If I were to put 7 natural log of 4 in my calculator, that's just a number. So our step in solving linear equations is get everything with a variable on one side, numbers on the other side. So I'm going to take the negative 7 natural log of 4 to the right side. When we do that, it becomes a positive. So we've got natural log of 13 plus 7 natural log of 4. Now we're trying to solve for x, so our last step is to divide both sides by what's behind our x. Now natural log of 4 is just a number, so we'll divide both sides by natural log of 4. And do that, those natural log of 4's cancel there. And we got x is equal to natural log of 13 plus 7 natural log of 4 over natural log of 4. Now the book will do a little bit of simplifying on this. If you're in my class, I'm happy when students get down to this point. Now if you're looking at this simplifying, you think, okay, I'll cancel those natural log of 4's. You can't do that because there's plus in here. Everything would have to be multiplication up on top for you to be able to cancel those natural log of 4's. What I mean by simplification is we have a property of log says if you have a number out in front of the log, you can take that and put it as your power. So we got x is equal to natural log of 13 plus natural log of 4 to the 7th power over natural log of 4. Now we have another property says if you have log of something plus log of something, you can rewrite addition as multiplication. So this becomes natural log of 13 times 4 to the 7th over natural log of 4. Now I'm not going to actually multiply that together, but once you did, that's as simplified as you get versus just plugging in your calculator and getting a decimal. Let me start a new page and have my tablet blow up. There we go. Bring up a new tablet. Yeah, let's look at the next problem. We got 2 to the 8x minus 1 equals 3 to the x minus 4. Now our first step says get the part of the variable and the exponent by itself. Well, this part has a variable in the exponent, and this part has a variable in the exponent. And actually, both of them by themselves. They don't have any numbers in front of it, any numbers after it. So that first step is okay. Step 2, take natural log of both sides. So we got natural log of 2 to the 8x minus 1 equals natural log of 3 to the x minus 4. Step 3, use properties of logs to get the variable out of the exponent. So we're going to take the 8x minus 1, put it out in front. When we put it out in front, we have to put parentheses around it, just like that previous problem. This one, we'll take the x minus 4 and put it out in front. And again, we'll put parentheses around it. Now we want to solve for x, and always your first step in solving a linear equation is get rid of parentheses. So this is just a number. We got a number next to the parentheses, so that's distributive property. So we'll take natural log of 2 times 8x and times negative 1, and we'll take natural log of 3 times x and times negative 4. So that gives us 8x natural log of 2 minus natural log of 2. Over here I'll take natural log of 3 times x. That gives us x natural log of 3. And natural log of 3 times negative 4 gives us negative 4 natural log of 3. Now, second step is to get rid of fractions, don't have any. Third step in solving a linear equation is to get everything with an x on one side, numbers on the other. So get everything with an x on one side. That means take the x to the natural log of 3 to the left side. Get all the numbers on the right side. This is just a number, so we'll take the negative natural log of 2 to the right side. So we got 8x natural log of 2 minus x natural log of 3 equals, and a negative natural log of 2 becomes a positive natural log of 2, minus 4 natural log of 3. Now we're trying to get x by itself, and normally we combine together like terms to get a single x. There's two ways you can get a single x. You can combine together like terms, which doesn't seem to fit very well with this problem, or you can factor out an x. And that's what we'll do here. We'll factor out an x. And that gives us 8 natural log of 2 minus natural log of 3 equals natural log of 2, and I'm going to switch over to ln because I'm getting tired of saying natural log. So minus 4 ln of 3. Now if I plug in 8 ln of 2 minus ln of 3 in my calculator, that just gives me a decimal. So we got a number next to x. So we're going to divide both sides by that number. So we're going to divide both sides by 8 ln of 2 minus ln of 3. And what was that? 8 ln of 2 minus ln of 3. I'm going to do that. These cancel here. And this gives us x is equal to ln of 2 minus 4 ln of 3 over 8 ln of 2 minus ln of 3. Now, I'm happy when my students get down to here, but if you're wondering how you can simplify it further, if you got a number out in front here, you can take that and put as your power. And same here, I can put that as my power there. So this gives us natural log of 2 minus ln of 3 to the 4th over ln of 2 to the 8th minus ln of 3. Now, I don't know if I know what those are or not, but let's see. Might get lucky. That's 81, I believe. 3 to the 4th. Let's see, 2 to the 5th is 32, so 6,420, 256, I think. Let me see, this is 2 to the 5th, that's 2 to the 6th, 2 to the 7th, 2 to the 8th, yeah. Now, it looks like, well, you can combine these together, but typically they will not put a fraction inside of a fraction. So this is usually where they'll leave off, and that's your answer. Okay, let's look at number 10. This is one of the 5%. You can't solve using that. We got e to the 4x minus 8 e to the 2x minus 20 equals 0. First step, get the part of the variable in the exponent by itself. Well, if I take the negative 8 e to the 2x minus 20 to the right side, this e to the 4x will be by itself, but the 8 e to the 2x won't be. It'll have a plus 20 with it. So there's no way I can get the part with the variable in the exponent by itself. This is a U-substitution. We'll let the variable part of the middle be u. That's excluding 8 not in front. And we'll let this be u squared. How do I know it's a U-substitution? When can you use the U-substitution? Well, if you can take the variable part of the middle, which is e to the 2x, and square it, and it gives you the variable part of the first, which it does in this case. Remember, when you raise an exponent to another exponent, you multiply them together. 2x times 2 is 4x. That's when you can use this. So we can rewrite this as u squared minus 8u minus 20 equals 0. And I want to factor that using the PST method. So that's u minus 10 times u plus 2 equals 0. Zero factor property from college algebra. You get 0 on one side, you factor the other side, and you set each factor equal to 0. I have to go watch some TV. They're showing previews of The Walking Dead. Okay. Take negative 10 over, becomes a positive 10. Take 2 over, becomes a negative 2. Focus, David, focus. Okay. Now, with our u substitution, after we get down to this point, we want to plug our u equals blank back in. In this particular problem, we said u is equal to e to the 2x. So where the u is, we're going to put in e to the 2x. And now at this point, this is an exponential equation, and it actually fits those 4 steps we got. First step, get everything. What is the first step? Get the part of the variable and the exponent by itself. That's by itself. Step 2, take natural log of both sides. So take ln of both sides. Now remember, natural log, your base is e. So when these e's match, the natural log and the e's cancel, and we got just the exponent, 2x, equals natural log of 10. Well, divide both sides by 2, and we get x is equal to natural log of 10 over 2. Now on the other side here, we take natural log of both sides, but there's a problem. We got natural log of a negative number. We can't have a log of a 0 or log of a negative number. So this part right here we can stop, and our only answer is this one right here. Let me start a new page, and then we'll put the steps up for solving a log equation. So log equations. First step. Get everything with a log on one side, numbers on the other side. I say numbers, but you could actually have even variables. But really, most college algebra books just have a mixture of logs and numbers. They don't have x's in there too, in terms of solving it by hand. Now, step 2. Use properties of logs to get a single log. Step 3. Use the definition of log to rewrite in exponent form. So to rewrite in exponent form. Step 4. Solve for x. That's pretty vague, but at this point it could be a quadratic equation, could be a rational equation, might be a linear, I don't know. And then step 5, check your answers. Now when I say check answers here, basically we're not going to do like a full check. We just want to make sure we don't have log of 0 or log of a negative number. And we'll see that with some examples. Now I would almost wager that these steps work 100% of the time. Now I am going to show you a shortcut. Normally I avoid those, but this shortcut is well worth it because it'll save you maybe 5 or 6 steps on these problems. Let's look at our first problem. We get log of base 4 of x minus 5 is equal to 3. Now, first step, get everything with a log on one side, numbers on the other side. Well, everything with the logs on the left side and numbers on the right side. Step 2, use properties of logs to get a single log. Well, we got a single log, so that's done. Step 3, use definition of log to rewrite in exponent form. Basically, what that says is you take your base, which is 4, to a power of the other side, equals what follows your log. So again, you take your base, which is 4, to a power of the other side, equals what follows your log. Now this says solve for x. This is actually a linear at this point. 4 times 4 is 16, times another 4 is 64. Now I'll take negative 5 over to the left side, and it becomes a positive 5. And that gives us 69. Then it says check your answers. If I put 69 minus 5 up here, that's not 0 and it's not negative. That's the only part I really care about checking. So that's our answer. Let's take a look at this one. Okay, first step, get everything with a log on one side, numbers on the other side. Well, that's done. Step 2, use properties of logs to get a single log. Now this is where I had an extra note in my 6-page document. Sometimes you can use basic math to get it by itself. Because if I use properties of logs, basically I'd take this 5 here and I'd put it as my power. Because we're trying to get a single log. We don't want any numbers in front of it. But if I put that as my power, I'm going to end up with x a fifth, which is a horrible problem to work. Well, there's an easier way to get the log by itself in this particular problem. We'll just divide both sides by 5. So if you can use basic algebra to get the log by itself, go ahead and do that. Now those 5's going to cancel, and we got natural log of 3x minus 1 equals 3. And now we got a single log. Step 2, use wait a minute, that was step 2. Step 3, use definition of log to rewrite in exponent form. So we're going to take our base, which in this case is e. Because remember, if you have ln, natural log, your base is always e. We'll take our base to a power of the other side, so we got e to the third power equals what follows our log. Now I want to solve for x, so I'll take negative 1 over, and it becomes a positive 1. And now we'll divide both sides by 3 to get the x by itself. So 1 plus e to the third over 3 is equal to 3x over 3. Those 3's cancel. And we got x is equal to 1 plus e to the third over 3. And that's our answer. You would plug it back up here, but it doesn't cause a log of 0 or log of negative numbers, so we're okay. Let's look at another problem. We got log of x plus log of x minus 6 equals 4. And again, we want to solve this. First step, get everything with a log on one side, numbers on the other side. That's done. Step 2. Ooh, he's ugly. Jason's on AMC, Fear Fest, and he's one ugly person. They got his mask off. No wonder he puts a mask on and hides in the lake. Okay, focus. Okay, first step, get everything with a log on one side, numbers on the other side. Well, step 2, we want to use properties logs to get a single log. Well, we got log of something plus log of something. Addition becomes multiplication. So we're going to have x times x minus 6 equals 4. Well, x times x is x squared. X times negative 6 is negative 6x. Third step, use definition of log to rewrite in exponent form. Because we got our single log, so now we're going to take our base, which is 2, to the power of the other side, so 2 to the 4th power equals what follows our log. Now in step 4 in this is a quadratic. We got an x squared. So we want to get everything over on one side and 0 on the other. First, 2 to the 4th gives us 16. Now take 16 over to the right side. Remember, when you take anything across your equals, your sign changes. So the 16 becomes a negative 16. And this factor is using the PSD method. This is x minus 8 times x plus 2. Zero factor property from college algebra. You get 0 on one side, you factor the other side, you're going to set each factor equal to 0. So I'll set x minus 8 equals 0 and x plus 2 equal to 0. And solve this, and we get x equals 8 and we get x equals negative 2, maybe. Let's check our answers. Check the 8. If I put 8 in for the x here, it's okay. 8 minus 6, that's okay. Negative 2. If I put negative 2 into this log here, negative 2, negative 6 is negative 8. We got log of a negative number. We can't have log of a negative number. So that negative 2 disappears. And our only answer is x equals 8. And I don't think I have room to work the next one, so let me start a new page. And we got x minus 1. X minus 5 equals 2. Okay, so our first step, get everything with the log on one side, numbers on the other side. That's done. Everything with the logs on the left side and numbers on the right side. Step 2, use properties logs to get a single log. Well, log of something minus log of something. Subtraction becomes division. So this becomes x minus 1 over x minus 5 equals 2. And we got a single log. Well, third step, use the definition of the log to rewrite an exponent form. So we're going to take our base, which is 3, to a power of the other side. So 3 to the second power is equal to what follows our log. Now this is a rational equation, and first thing I'll do is get rid or simplify that. 3 squared is 9. Now to solve a rational equation, we'll multiply both sides by the LCM of all our denominators. Now we only have one denominator, so our LCM is x minus 5, and we'll multiply both sides by that. This is step 4, solve. When I do that, those x minus 5 is going to cancel. Over here we got 9 times x is 9x. 9 times negative 5 is negative 45. Equals x minus 1. Get everything with an x on one side, numbers on the other. So I'll take the x to the left side and the negative 45 to the right side. You take anything across your equals, the sign changes. So the x becomes a negative x. The negative 45 becomes a positive 45. Now 9x minus x, combined together like terms, gives us 8x. Negative 1 plus 45 gives us 44. Divide both sides by 8. So we got 8x divided by 8 equals 44 divided by 8. And those cancel. Now this simplifies. They're both divisible by 4 at least. So that's 11 halves? Like that. 11 halves, that's like what, 5.5, 5.5 or something like that? Okay. Let's check our answer. If I put 5.5 up here, 5.5 minus 1, it's not 0, it's not negative, so we're fine. If I put 5.5 here, 5.5 minus 5, that's positive. It's not negative, it's not 0. So this is actually our answer. Again, when you check it, all you have to do is check to make sure you don't have log of 0 or log of negative number. We can't have that. And time for our shortcut. Take a look at this problem. Log something minus log of something equals 2. Compare that to this problem. Log of something minus log of something equals log of something. Everything has a log on it. If everything has a log on it, that's where we can use our shortcut. And it actually does save you steps. So our note, if everything has a log on it, no matter what base. So it could be ln even. So if everything has a log on it, use properties of logs to get a single log on both sides. So use properties of logs to get a single log on both sides, and then drop the log part, the log part. Everything else remains, you just drop the log off of it. Let's take a look at a problem. We got log x plus 1 minus log 5 equals log of 4x minus 2. Well, everything has a log on this, so we can use this this note. It says use property logs to get a single log on both sides. Well, over on the left side here we have log of something minus log of something. Subtraction becomes division. So we'll rewrite this as log of x plus 1 over 5 equals log of 4x minus 2. So we got a single log on both sides. It then says drop the log part. So we'll just cross off those logs, and we got x plus 1 over 5 equals 4x minus 2. Now we need to solve this, and we got a fraction. Always first step is to get rid of fractions. So we'll multiply everything by the LCM of all our denominators. We only have one denominator, the 5, so we'll multiply both sides by 5. So here these 5's cancel. And we got x plus 1 is equal to 5 times 4x is 20x. 5 times negative 2 is negative 10. We want to get everything with an x on one side, so I'll take the x over to the right side and negative 10 over to the left side. So we got 1 plus 10 equals 20x minus x. Well, 1 plus 10 gives us 11. 20x minus x gives us 19x. Divide both sides by the number in front of our x, so we'll divide both sides by 19. And those 19s cancel. And we get x equals 11/19. Okay, check our answer. 11/19 plus 1, I don't know what it is, but it's not 0, it's not negative. That's all I care about. 4 times 11/19 gives me 44 over 19, which is greater than 2. So when I subtract 2, it's still positive. So this is fine. That's our answer. Let me start a new page and we'll look at our last problem. So we got natural log of x plus 2, ln of x plus 2, minus ln of x plus 4 equals ln of x plus 7 minus ln of x plus 11. You notice something here. Everything has a log on it. ln is the same as log. So we'll use our properties of logs, get a single log on both sides. So here we have log of something minus log of something. Subtraction becomes division. So we got x plus 2 over x plus 4. Over on this side, we have natural log of something minus natural log of something. Subtraction again becomes division. So this is natural log of x plus 7 over x plus 11. Now once you get a single log on both sides, you can drop the log part, or in this case the ln. And we got x plus 2 over x plus 4 equals x plus 7 over x plus 11. Now this is a rational equation. And our way of solving a rational equation is we multiply everything by the LCM of all our denominators. Now since we have this denominator and they can't factor, our LCM will just be the two multiplied together. So it'll be x plus 4 and x plus 11. So I'll multiply that times the first fraction, and I'll multiply it times the second fraction. Okay, the x plus 4 cancels this x plus 4. This x plus 11 cancels that x plus 11. Now here, we got x plus 11 times x plus 2. And here we got x plus 4 times x plus 7. Well, we'll multiply all these together. X times x is x squared. X times 2 is 2x. 11 times x is 11x. 11 times 2 is 22. X times x is x squared. X times 7 is 7x. 4 times x is 4x. And 4 times 7 is 28. Now notice we have an x squared on both sides. If you have the same item on both sides, you can just drop them. 2x plus 11x is 13x plus 22. Combine together like terms. 7x plus 4x is 11x plus 28. Well, get everything with an x on one side, numbers on the other. This is just a linear equation at this point. So we got 13x minus 11x equals 28 minus 22. You take anything across your equals, your sign changes. Combine together like terms. 13x minus 11x is 2x. And 28 minus 22 gives us 6. Last step. Divide both sides by a number in front of your x, which is 2. And we get x is equal to 3. Maybe. Let's plug this back in, see if it causes us problems. So if I put 3 here, 3 plus 2, that's not 0 or negative. 3 plus 4, that's not 0 or negative. 3 plus 7, that's not 0 or negative. 3 plus 11, that's not 0 or negative. So that's our answer. Assuming I didn't make a math error. Let me double check myself there. Yeah, I was watching TV when I should have been focusing on the problem. Get that monkey off my back. I love horror movies, Jason and Halloween and all that. So it's really hard for me to sit here and do math when that's on. Yeah, everything looks good. So that's our answer. And I think that's the last problem. Yes, it is. So let me save this.